Too fast, or are we good, you guys?
Okay.
Okay, so that's number 4. Everybody happy?
Yes.
Number 6. Yeah, shoot.
So in the future, will you just use that formula?
I mean, I guess so, but it's only true in very. She asked if you could use that formula in the future.
Because I used it in six and it helped.
Oh, great. Okay, yeah. I mean, as long as you understand where it comes from.
Other problem is so great.
Sorry?
I used it in like almost every other problem.
Did you really? Okay.
It's
So
the entire process.
it's only true though if you are moving 2 blocks with one external force and they move with the same acceleration.
Oh, no.
One external force, right? So no friction. Yeah, it's assuming no friction between the blocks and the ground. Okay. All right, number 6. It says in figure A below, we've got this. Here's block A, here's block B. We're going to push them with some applied force, which they've called FA, as in, I think that A stands for applied. Okay, so I think that's why that was there. All right, so it says we're applying that force. It pushes against, it's applied to block A, which pushes against block B with a force of 20 newtons. So in this situation, what we know is that the force of block A on block B, which is the same as the force of block B on block A, has a magnitude of 20 newtons. In other words, the 2 blocks are pushing each other with 20 newtons in that circumstance. Good? All right? In the other figure, your 2 objects are switched. You've got the same applied force, but now the forces that the 2 objects exert on each other is only 10 newtons, right? And then it tells you that the blocks have a combined mass of 12 kilograms. I don't know where I want to write this. So, mass of A plus mass of B equals 12 kilograms. Useful information. My phone is ringing. Okay, so we're trying to find the magnitude of the acceleration and the combined force. So, to me, this seems like a system of equations, right? There's 2 unknowns. We don't know the force, and we don't know the acceleration. And I guess we don't know either of the masses either. So, there's a bunch of stuff we don't know. All right, so can anybody get me started? Was anybody able to come up with anything on this? You got an idea, sir? Let's get it started.
Yeah, sorry, I got this one, but it wasn't. Where are you in this?
Well, all I've done is written down the given information.
I said that F divided by 12 equals A because that's like the
Okay, so you're looking at the system. So in either of these 2 systems, our combined mass is 12 kilograms. So that makes sense to me. So I agree that over here, if I do FA divided by 12, that's my acceleration. And I guess the same thing is true over here, right? Everybody good with that? Sure, Peter?
Well, what I did is I kind of, like what Carl was talking about, drew back to number 4. And so you can take that like 20 newtons
Gotcha.
is equal to the mass of B times the total force over 12.
Okay.
And then the 10 is equal to the mass of A times the total force over 12.
I'm going to interrupt you really quickly here. So you guys already have a ton of equations to memorize. And I'm just worried that, like, when the AP test comes around, the odds of you remembering that one equation from this one assignment are slim. Do you know what I mean? That's like a real specialized equation. So let's see. I agree that what you're doing works. There's nothing wrong with it conceptually or logically. But I think it sort of diverts from the intent of the problem.
Got it.
Do you know what I mean?
Yeah.
So I don't mean to be, I hope you understand what I'm trying to get at. I'm just trying to think about, like, when you get to the AP test, you're probably not going to remember that equation. It's certainly not on the equation sheet you get.
Right.
Okay. So, Sarah?
So, like, what I did the rest was, like, net force equals first, so I set up like two equations. I had like x equals like the unknown mass of either a or b.
Okay.
So I had like a equals 12.
A, when you say A, do you mean acceleration?
Yep. So acceleration multiplied by 12 minus x equals 20, and then a times x equals 10, and then you substitute it.
So when the first one you said 12 minus, what's your x? Your x is,
Either the mass of a or b. Wait, x is the mass, I think, of a.
okay, I think so too. Okay, so I think what I'm hearing you say is over here you set up, you looked at your free body diagram for box A, right?
Yeah.
And you're saying, okay, well in this drawing I've got my applied force on it, and then 20 newtons pushing back on it, right?
Yeah.
Is that correct?
I thought it. Yeah. Okay.
Good? No, it's negative. You're right.
Okay.
So then I think that I'm hearing you say that you found your net force here. So applied force minus 20 newtons has got to equal the mass of A times our acceleration. Yes?
You're definitely better. I think that was.
Same concept though?
Yeah.
Everybody good with that?
Yeah.
All right, so now I've got one equation here that's got two variables, right? Applied force and mass of A, right? Huh. So I wonder if I repeated that same process over here, what would happen? So mass of A. So in this drawing, what's the only force on box A? The force of B, right? Which is the 10 newtons, right? Follow? This is slick, sir. I like this. This is really cool. So, so now I can do net force equals net force. So my net force is 10 newtons. That's got to equal ma times force of A, the force applied over 12, right? So now we've got two equations, two unknowns, and you can solve for the missing things. Very slick. So let me pause for a minute and make sure everybody's cool. So these are the two equations. My variables are applied force and mass of A. Variables are applied force and mass of A. So two equations, two unknowns, solve. Yeah, so.
So on the right for box A, it doesn't, it does push back on B, but that's not relevant because we're just drawing the force on A.
Correct. All right, now to be clear, there's nothing magic about the fact that Sarah chose box A here. You absolutely could have done this exact same process by looking at box B. Followed? Okay, there are definitely other ways to do it, but this way works for sure. All right, problems, you guys? Do I need to finish it? Can I stop there? From here, it's algebra, right? Okay, any questions on it? All right, nice job, I like that, that was cool. All right, number 8.